This will be the first time in history that I'm aware of that this has been done. This is a 3D printed, flexible photovoltaic panel. Hey guys, how's it going? So I heard through the grapevines that there is this incredible company called Timeplast making 3D printed filaments that can create solar panels, essentially a photovoltaic 3D printed filaments. Can you believe that? That sounds amazing though. Not just kidding, I am the founder of Timeplast, of course. And here is the first photovoltaic TimeMass filament. We're gonna put it to the test and we're gonna see if it actually works. We're here at the shop and I have the filament drying in here and the printer is preparing. I'm just gonna be printing a simple panel. As you can see, it's just a regular flat panel. I'm actually printing different sizes. This is another size that we're printing. It's very shiny. Actually, if the print doesn't come out as shiny, somehow it is like this, it's a failed print. So as you can see, there's one gray on the left and one shiny on the right. So it's supposed to be shiny, guys. If it's not like that, it's because you're not drying the filament enough. And that matte gray are essentially micro bubbles. They're gonna be stopping the photovoltaic process from taking place. All right, so we're gonna wait for an hour up until the print is ready here. And we're gonna see how it goes. All right, so here we are. Let us see, we're 81%. And this is how the panel is doing. Now, I didn't put any glue, any adhesive, and I'm just using a texture plate here, which is why you're looking at this warp. It's detaching a little bit. Now, it's not affecting the quantity of the print, as you can see. It's not affecting the quantity at all. It's lustrous, shiny, as we are expecting. But this is a flexible filament, which is great because if you want to have a solar panel that you can wear or something, flexible, then this is your option here. And I don't think it's going to make the print fail, but we'll see. So far, so good. So look, it's printing on this side, on the corners, which are warping, but the actual panel is not moving at all. So I think it's going to continue to do well. The reason why I didn't put any glue, it's because this is going to be a conductive surface. So 10 plus 70% water, which is a polar solvent, which means that the entire macromolecule is going to be polar as well. And that is important for conductivity. So the carbon nanotubes, graphite, and the microcrystals, zinc nanocrystals are going to create this photovoltaic effect. And you don't want to have a surface of glue, non-polar, non-conductive glue in your panel because, it may have some interaction. This is the glue that I typically use. And of course, by using this glue, this is from Bamboo Labs, you don't have any of these warping problems. You gotta say that this is the one that has worked the best for me. This is just a hair product and it works great too. Now, of course, you absolutely don't want to have that. Oh, it just failed right now. So I may need actually some glue, although I'm going to try and see if this works as it is because it is a good surface area. So I'm just going to try it out like this and see if it creates any photovoltaic effect. All right, so let's talk about the things that we need. So to make this panel work, even though it's hot printed, but I just want to try it out and see if there's any photovoltaic effect. So you need a copper mesh like this. You need copper tape like this, a table to work on. I'm sorry about the mess, you know how it is. If you want to do quick trials, an UV flashlight, it's gonna do great too. And with all of that, we should be good to go. All right, so what is the next step? The next step here is to cut a cardboard the same size of the panel, right? You match it there. And then a copper mesh 1 centimeter smaller per side. So it would look something like this, as you can see here, essentially smaller on all sides so that the electrons don't flow off the panel. So you gotta remember, this mesh is like a highway for the electrons to go from the surface of the panel all the way through the filament into the mesh. Now we need to make the bus bars, which are going to be at the top and the bottom, and we need to create an avenue in the middle so that electrons can move up and down. And then hopefully in the presence of the sunlight, we're going to be able to measure voltage between the two bus bars. Okay, let's continue to go. All right, so we're trying to do this in one shot, but essentially this is the final panel. As you can see, we use a cardboard and we have the bus bars here. Here you can see the mesh. I don't know if the camera is capturing the copper mesh in there. Now we put some crazy glue on this side, and we're going to be putting crazy glue on this side now. We're going to be closing it in one shot, so you know there's nothing else in here. So now, if you're going to be using glue inside to keep everything tight, it has to be a conductive glue. All right. So let's take the periodic table, because this is a historic moment, and let's take our voltmeter to outside when there's some sun. All right. So the sun is out. That's great. And we're going to be measuring our panel. Again, if this manages to create some voltage, this will be the first time in history that I'm aware of that this has been done. This is a 3D printed, flexible photovoltaic panel. Let's see if it creates any current. So within the prayer cable here, as the base, we're putting the voltmeter on your auto voltage there. And let's make sure that the camera sees the voltage as I'm doing this. Is that okay? All right. Let's see what happens. And we have voltage, guys. Look at that. This is huge. Oh my God. Thank you so much. And I hope you enjoy this new filament by Timeplast.